Welcome back. In the last video, we made some classification data so that we can practice building a neural network in PyTorch to separate the blue dots from the red dots. So let's keep pushing forward on that. And I'll just clean up here a little bit. But where are we in our workflow? What have we done so far? Well, we've got our data ready a little bit. We haven't turned it into tensors. So let's do that in this video, and then we'll keep pushing through all of these. So in here, I'm going to make this heading 1.1, check input and output shapes. The reason we're focused a lot on input and output shapes is why? Because machine learning deals a lot with numerical representations as tensors, and input and output shapes are some of the most common errors. Like if you have a mismatch between your input and output shapes of a certain layer, of an output layer, you're going to run into a lot of errors there. So that's why it's good to get acquainted with whatever data you're using, what are the input shapes, and what are the output shapes you'd like. So in our case, we can go x.shape and y.shape. So we're working with NumPy arrays here. If we just look at x, that's what the make circles function has created for us. We've got an array, but as our workflow says, we'd like it in tensors. If we're working with PyTorch, we want our data to be represented as PyTorch tensors of that data type. And so we've got a shape here, we've got 1,000 samples, and x has 2 features, and y has no features. It's just a single number. It's a scalar, so it doesn't have a shape here. So there's 1,000 samples of y, 1,000 samples of x, 2 samples of x equals 1 y label. Now, if you're working with a larger problem, you might have 1,000 samples of x, but x is represented by 128 different numbers, or 200 numbers, or as high as you want, or just 10 or something like that. So just keep in mind that this number is quite flexible of how many features represent a label. Y is the label here. But let's keep going. So view the first example of features and labels. So let's make it explicit with what we've just been discussing. We'll write some code to do so. We'll get the first sample of x, which is the 0th index, and we'll get the first sample of y, which is also the 0th index. We could get really anyone because they're all of the same shape, but print values for one sample of x. What does this equal? X sample, and the same for y, which is y sample. And then we want to go print f string for one sample of x. We'll get the shape here, x sample.shape, and the same for y, and then we'll get y sample.shape. Beautiful. What's this going to do? Well, we've got one sample of x, so this sample here of these numbers. We've got a lot going on here. 75424 and 0231488074. I mean, you can try to find some patterns in those. If you do, all the best to you. And the same for y. So this is, we have the y sample. This correlates to a number 1, a label of 1. And then we have shapes for one sample of x, which is 2. So we have 2 features for y. It's a little bit confusing here because y is a scalar, which doesn't actually have a shape. It's just one value. So for me, in terms of speaking this, teaching it out loud, will be 2 features of x trying to predict one number for y. And so let's now create another heading, which is 1.2. Let's get our data into tensors. Turn data into tensors. We have to convert them from NumPy. And we also want to create train and test splits. Now, even though we're working with a toy data set here, the principle of turning data into tensors and creating train and test splits will stay around for almost any data set that you're working with. So let's see how we can do that. So we want to turn data into tensors, and for this we need to import Torch. We'll get PyTorch and we'll check the Torch version. It has to be at least 1.10. And I might just put this down in the next cell. Just make sure we can import PyTorch. There we go, 1.10 plus CUDA 111. If your version is higher than that, that is okay. The code below should still work, and if it doesn't, let me know. So x equals torch dot from NumPy. Why are we doing this? Well, it's because x is a NumPy array. And if we go x dot, does it have a d type attribute? Float 64. Can we just go type? Or maybe type, oh, there we go. NumPy ND array. Can we just go type x? Oh, NumPy ND array. So we want it in a torch tensor. So we're going to go from NumPy, we saw this in the fundamental section, and then we're going to change it into type torch.float. Float is an alias for float32. We could type the same thing. These two are equivalent. I'm just going to type torch float for writing less code. And then we're going to go the same with y, torch from NumPy. Now, why do we turn it into a torch float? Well, that's because if you recall, the default type of NumPy arrays is, if we go, might just put out this and a comma, x.dtype is float64. There we go. However, PyTorch, the default type is float32, so we're changing it into PyTorch's default type. Otherwise, if we didn't have this little section of code here, .type torch.float, our tensors would be of float64 as well, and that may cause errors later on, so we're just going for the default data type within PyTorch. And so now let's have a look at the first 5 values of x and the first 5 values of y. What do we have? Beautiful, we have tensor data types here. And now if we check the data type of x and we check the data type of y, what do we have? And then one more, I'm just going to type x. So we have our data into tensors. Wonderful, but now, so it's torch.tensor, beautiful. But now we would like training and test sets. So let's go split data into training and test sets. And a very, very popular way to split data is a random split. So before I issued the challenge of how you would split this into a training and test set. So because these data points are kind of scattered all over the place, we could split them randomly. So let's see what that looks like. To do so, I'm going to use our faithful scikit-learn again. Remember how I said scikit-learn has a lot of beautiful methods and functions for a whole bunch of different machine learning purposes? Well, one of them is for a train test split. Oh my goodness, PyTorch, I didn't want autocorrect there. Train test split. Now you might be able to guess what this does. These videos are going to be a battle between me and Codelab's autocorrect. Sometimes it's good, other times it's not. So we're going to set this code up. I'm going to write it, or we're going to write it together. So we've got xtrain for our training features and xtest for our testing features. And then we also want our training labels and our testing labels. That order is the order that train test split works in. And then we have train test split. Now, if we wrote this function and we wanted to find out more, I can press Command Shift Space, which is what I just did, to have this. But truly, I don't have a great time reading all of this. You might, but for me, I just like going train test split. And possibly one of the first functions that appears, yes, is scikit-learn. How good is that? So scikit-learn.model-selection.train-test-split. Now, split arrays or matrices into random train and test subsets. Beautiful. We've got a code example of what's going on here. You can read what the different parameters do, but we're going to see them in action. This is just another example of where machine learning libraries such as scikit-learn, we've used matplotlib, we've used pandas, they all interact together to serve a great purpose. But now let's pass in our features and our labels. This is the order that they come in, by the way. Oh, and we have the returns splitting. So the order here, I've got the order, goes xtrain, xtest, ytrain, ytest. Took me a little while to remember this order, but once you've created enough train and test splits with this function, you kind of know this off by heart. So just remember features first, train first, and then labels. And we jump back in here. So I'm going to put in the test size parameter of 0.2. This is percentage-wise, so let me just write here, 0.2 equals 20% of data will be test, and 80% will be train. If we wanted to do a 50-50 split, that kind of split doesn't usually happen, but you could go 0.5. But the test size says, hey, how big in percentage-wise do you want your test data to be? And so behind the scenes, train test split will calculate what's 20% of our X and Y samples. So we'll see how many there is in a second. But let's also put a random state in here. because if you recall back in the documentation, train test split splits data randomly into random train and test subsets. And random state, what does that do for us? Well, this is a random seed, equivalent of, it's very similar to torch.manual seed. However, because we are using scikit-learn, setting torch.manual seed will only affect PyTorch code rather than scikit-learn code. So we do this so that we get similar random splits, as in I get a similar random split to what your random split is. And in fact, they should be exactly the same. So let's run this, and then we'll check the length of xtrain and length of xtest. So if we have 1,000 total samples, and I know that because above in our make circles function, we said we want 1,000 samples, that could be 10,000, that could be 100. That's the beauty of creating your own data set. And we have length ytrain. If we have 20% testing values, how many samples are going to be dedicated to the test sample? 20% of 1,000 is 200, and 80%, which is, because training is going to be training here. So 100 minus 20% is 80%. So 80% of 1,000 is, let's find out. Run. Oh, beautiful. So we have 800 training samples, 200 testing samples. This is going to be the data set that we're going to be working with. So in the next video, we've now got training and test sets. We've started to move through our beautiful PyTorch workflow here. We've got our data ready. We've turned it into tensors. We've created a training and test split. Now it's time to build or pick a model. So I think we're still in the building phase. Let's do that in the next video.